मी तिच्या आत्याला कालच म्हटले, आत्या म्हणाले मी तुला
Okay guys, so good morning and welcome to the session. Okay guys, so let's get started in the next few minutes while others join. And in meantime, please open that article once again. Okay, let's get started. How many people have joined? 13. Class का official timing क्या दिया था? ठीक है, fair enough. So then we should get started. Okay. So, and one of my expectation is that people are clear till the point where we have discussed in the last class. Okay? So let's continue from the same point. And before I continue, let's read this slider which I have created for you guys. Do a simple read, please. Yes. 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 So we have already discussed this type problem, but only thing is like over here I have just jotted down. Okay. So please make a note of it, or if you want, you can take a screenshot of it. So drawbacks of RNN, they suffer from exploding or vanishing gradient descent. So vanishing gradient descent we have already discussed. And if you try to overcome that vanishing gradient descent and you may increase the LR, then it may go into your exploding gradient descent. RNNs perform poorly when sequence is long. We have already discussed this thing. Another problem with RNN is that the memory of initial input gets faded, diluted, and finally gets lost. So this problem is nothing but I am describing it in a little more technically. Basically, if your gradient is vanishing, your initial inputs are getting vanished. RNNs may take huge amount of time to train as well. So if our algorithm is suffering from vanishing gradient descent, obviously the time taken would be much more. RNNs are good in remembering the recent past, but not very long-term dependencies. So if you see that your model doesn't has a very huge amount of text, these statements are very small, then probably you can use the vanilla RNN also. You don't need to move to LSTM. But if you see that RNNs are suffering, that your model is suffering from these type of problems, probably you can use LSTM. Normally, with time, it has been observed that there is no use of using the normal RNN, but just go ahead and use LSTMs. So whether you have long-term dependencies or whether you don't have long-term dependencies, in both the scenarios, LSTMs will work good. Okay. Now, let's come back to this point. Okay, so core idea behind LSTMs. Okay, so before I move ahead, those who are in online, guys, please confirm if I'm audible.
Yes, sir.
Yes, sir.
Okay, thank you. So the key to LSTM is the cell state, the horizontal line running through the top of the diagram. This we have already discussed, but I'm again discussing it once more. The cell state is kind of your conveyor belt. It runs through down the entire chain. So you can take conveyor belt as your brain or human memory. Okay? So like your human memory, it is continuously getting the data and it is continuously forgetting the data. The same thing like your conveyor belt. Conveyor belt keeps on moving. The new items land on conveyor belt and with time they also get removed. So conveyor belt is a significance of your human brain, or you can say it's a memory state. So memory learns something and you forget something also. It runs straight through the entire chain with only some minor linear interactions. It is very easy for information to just flow it unchanged. So the same thing I have discussed on Saturday class, that if you don't learn any new thing and if you do not forget any past thing, then your previous cell state and the new cell state would be same. Kuch bhula nahi, kuch yaad nahi kiya, so there is no change in the state. The LSTM does have ability to remove or add information to the cell state. Okay. So you are seeing one cross over here and one plus over here. So cross means you are flushing out the old information and plus means you are adding a new information. CT minus 1 is a memory state at time t minus 1 and CT is a state at time t, right? So just one interval before and after, right? So you are removing something and you are adding something. If you do not remove anything and if you do not add anything, then CT minus 1 and CT would be same. And now the only question is, how do you remove and how do you add? How do you remove and how do you add? The gates are the way to optionally let information through. They are composed out of sigmoid neural network net layer and pointwise multiplication operation. The sigmoid layer outputs the numbers between 0 and 1. So this is nothing new for us. We already know that sigmoid gives me the answer in classes 0 and 1. But in between, you have answers in probabilities. Probabilities get converted to 0 and 1, describing how much of each component should be let through. Value of 0 means let nothing let through, while the value of 1 means let everything through. And LSTM has 3 of these gates to protect, control, and select. Actually, यहाँ पे 3 लिखा है, but there are actually 4 gates. 4 gates होते हैं. ठीक है, LSTM has basically 4 gates. Now, one thing would be coming 0 and 1. How would I get answers in probably in the numbers or something? मैंने यहाँ पे अपना PPT का cut डाला है. See, you already know that information is passed in vector format. ठीक है ना? Information is passed in vector format. Or basically, first of all, I'll say the words are converted to numbers. are converted to numbers, and these numbers are passed in vector format. These are passed in vector format. Okay. So these would be your vectors, right? So let's say if this is at your time t minus 1, this is at t minus 1. And this is also your t at, let me say, at time t. If these, so let me say the number over here was A, B, C, D, E, and over here also A, B, C, D, and E. So if the numbers are same, so where A and B represent A, B, A, comma, B, comma, C, comma, D, comma, E, they are representing some unique numbers, right? If the numbers are same, then your output would be kind of 1. Output would be kind of 1. It has nothing to forget because the input is still same. If the same information is passing, there is no change in the context. There is no need to forget anything. वही same चीज उसने यहाँ पे लिखी हुई है. Value of 0 means let nothing through, while the value of 1 means let everything pass. Okay. The first step in our LSTM is to decide what information we are going to throw away. Okay. So the first thing is how much information I'm going to flush away, and then we will add the new information from the cell state. This decision is made through sigmoid layer called the forget gate layer. अब यहाँ पे diagram को देखो कि forget gate कौन सा होता है. So this is your forget gate. This is your forget gate. This is your forget gate. Okay. And this is your input gate. This is your input gate. Okay. Now, one thing probably this person could have done a little better, and which confuses many people at the starting, is have a look over here. This diagram को देखो. So, can you notice that there are two lines running? One is this line and one is this line. So CT minus 1 is a cell state at time t minus 1. So CT minus 1 is a cell state at time t minus 1. But what do you mean by cell state? What does cell state represents?
Holding the current information.
It holds the current information, a perfectly right answer. So whatever has happened till time t minus 1, whatever you have forgotten or whatever you have learned in past till t minus 1 is the current state. Okay. So CT minus 1 is the current. Memory state is nothing but your current state, or you can say the current position, current information. And then you flush something, and then you are adding something. Okay. So depending upon how much or what has been flushed and what has been added, there would be a difference between your CT minus 1 and CT. In article nowhere it has been written, उसने assume कर लिया कि article सब PhD वाले लोग ही पढ़ेंगे. This CT minus 1 and HT minus 1 are same thing. You notice that? They are same. Only notation is different. Are you getting my point? CT minus 1 और ये HT minus 1 ये same चीज represent करता है. Okay. So he should have specifically mentioned, but उसने mention नहीं किया है. CT minus 1 and HT minus 1 are same. For explanation purpose, he has drawn this line 2 times. Now, check this part, guys, which I'm marking in red. Check this part, which I'm marking in red. Over here, do you notice you are doing HT minus 1 and then you are using this line. देख रहे हो ये line यहाँ पे merge हो रही है. And if you notice the convention used, क्या है वो convention? It has concatenated the information. ठीक है. HT minus 1 and CT. So what it is doing? So HT minus 1 is the cell state, or you can say previous information at time t minus 1, and XT is the new information. And if you have to decide which information you need to flush out, you need to compare with the new one. Otherwise, कैसे decide करोगे? So HT minus 1 and XT are being concatenated. And after this concatenation, do you notice it is passing through your sigmoid? After this concatenation, it is passing through your sigmoid. And this sigmoid will give you the answers between your 0 to 1. Okay. So 0 means nothing to pass. Nothing passes. And 1 means let everything pass. Okay. Let everything pass. This is the basic. So diagram देखने में confusion है, but I have explained it in a very simpler terms. So over here, this is your, this entire thing, this entire thing is nothing but your forget gate. So in forget gate, what is happening? The information from the previous cell and the new, information from the previous time interval and the information at the current time interval, they are getting concatenated, passing through your sigmoid function. And sigmoid function will give information between 0 to 1. अब यहाँ पे वापस आओ, देखो वही same चीज वो बताता है. Sigmoid layer outputs numbers between 0 and 1, describing how much of each component should be passed through. A value of 0 means let nothing through, while the value of 1 means let everything through. LSTM, ठीक है? The first step in LSTM is to decide what information we are going to. The decision is made by sigmoid layer called forget layer. इतना याद रखो, एक सेंटेंस नोट डाउन करो. फॉर सपोज करो कोई चीज पूछता है कि in forget gate what is the function I am using, so answer is sigmoid. In forget gate, what is the gate I am using? I am using the sigmoid function. Decision is made by sigmoid layer called forget layer. It looks at HT minus 1 and XT. Okay, अब यहाँ पे उसको बोलना चाहिए था HT minus 1 and CT minus 1 are same thing, but उसने कहीं बोला नहीं ऐसा. And outputs a number between 0 and 1 for each cell state CT minus 1. So he is assuming that people will understand. Okay, HT minus 1 and CT minus 1. 1 represents completely keep this, while 0 represents completely get rid of it. Okay, now he takes an example. He says, let's go back to our example of language model trying to predict the next word on all the previous one. Okay, so reading the previous statement, you are trying to predict the next word. In such problem, the cell state might include the gender of the present subject so that correct pronouns can be used. So whether it is based upon gender, you will use your his, her, him, he, she, him, her, whatever, right? So that correct pronouns can be used. When we see a new subject, we want to forget the gender of the old subject. Suppose I was talking about Ram, so I would be using he. But अगर सीता आ जाती है, तो I should be using she. ठीक है? So I need to, when we see a new subject, we want to forget the gender of the old subject. And this is the equation. देखो, FT is equal to sigma WF HT minus 1 XT plus BF. ये equation ध्यान से देखो तो तुम लोग को इस equation में mastery है वैसे. देखो, it is the same very equation which we have been using in a neural network. इसको यहाँ से कट करके यहाँ पे paste करता हूँ. देखो, now. So basically this equation is explaining this part. Now, basically, if you see this thing, I am saying HT minus 1 and I am saying XT. And I am also saying they are getting concatenated. So basically what will happen? HT minus 1 comma XT, right? And then you multiply with your weights. Multiply with your weights. And remember summation Wi Xi plus bias. Plus bias. And this information is passing through a function that is your sigmoid function. Normally हम ReLU से pass कर देते थे, remember? Summation wi xi plus b, it passes through ReLU, and then based upon that, it used to give your output. But this time it is passing through your sigmoid. ReLU यहाँ पे काम नहीं करेगा, because it will only identify whether if anything less than 0, तो उसको 0 ही mark कर देगा, ठीक है ना? So summation wi, and this passes through your sigmoid, and we know that sigmoid gives answer in probabilities between 0 to 1. If the values are close towards 0, the weightage will keep on decreasing. You may not forget everything. You may decrease the weightage, and if it is towards 1, it means you are carrying the total information. Okay? For each word, probably it can assign a weightage. And so now what is FT? FT is the output from forget gate. FT is the output from forget gate. And do you notice this FT is getting attached to your CT minus 1. So this much information would be flushed out. It will remove that information. CT minus 1, that much information would have been removed. Linear interaction. So FT is equal to summation WF HT minus 1 XT plus PF. The next step is to decide what new information we are going to add to the store in the cell state. This has two parts. First, the sigmoid layer called input gate layer decide which values we will update. Next, TANH layer creates a vector of new candidate CT. This could be added to the state. In next step, we will combine these two to create an update to the state. In the example of language model, we did want to add a gender of new subject to the cell state to replace the old one we are forgetting. Let's read it once more. The next step is to decide. So after our forget, we are moving toward the input. जो भूलना था जो भूल गए, अब क्या नया ऐड करना है. The next step is to decide what new information we are going to store in the cell state. This has two parts. Okay, I'll explain them. So can you notice in this diagram? So the input gate consists of two things. One is your sigmoid, another is your TANH. This has two parts. First, the sigmoid layer called the input gate layer decide which values we will update. Next, the TANH layer creates a vector of new candidates. Okay. Which values we will update, and then after deciding which values we will update, we create a vector of those updated values. Okay. Create the vectors of new candidates values CT. This could be added to the state. In the next step, we will combine. In this example of a language model, we did want to add a gender of new subject to the cell state to replace the old state. Now, let's do one. भर गया. चलो यहाँ पे स्टार्ट. So this is nothing but your input gate. This is nothing but your input gate. Now, do you notice one more thing? So what is, so in input gate, for the input gate, what is the input? Input gate का input क्या है? Do you notice one thing? हाँ बोलो, शायद तुम्हारा आंसर राइट हो. Yes, perfectly right answer. So basically, do you notice one thing? Over here, you have done the concatenation. Concat कर दिया. That same information is going to your input gate also and to your forget gate also. जो forget gate है उसमें भी same information यही थी, concatenation of HT minus 1 and XT. The same thing. So at this point, if I remove this thing, so do you notice concatenation takes place over here? यहाँ पे concatenation हुआ. and then the same thing is going to your forget gate, and the same information is going to your input gate, right? And इसी वजह से देखो तो उसने वही सेम चीज लिखी हुई है, wi ht minus 1 comma xt plus vi, right? And the same information. So at, let me say, point number A, point number B, and point number C, do you notice the information is same? Same input ही तो जा रहा है. Same input you are passing. There are no changes after point number A. After concatenation, A, B, C, N are same. So we already know what would be the information after sigmoid gate. It would give me the information between my 0 and 1. And the same thing is moving towards your WHT minus 1 and XT. The input is same, but do you notice the weights at sigmoid is उसने WI रखा है, and weight at tan H is WC. The weights can change, but the information is still same. Information is still same, and the biases can also change. The biases can also change. Okay. Biases can also change. It is now time to update the old cell state CT minus 1 into the new cell state. The previous step already decided what to do. We just need to actually do it. We multiplied the old cell state FT, forgetting the things we decided to forget earlier. Then we add IT cross CT. This is a new candidate value scaled by how much we decided to update each state value. यहाँ पे अगर मैं तुम्हें अपना कुछ आर्टिकल पढ़ा सकूं, ये देखो. In this case of language model, this is where we actually drop the information about the old subject gender and add the new information as we decided in the previous step. So now CT is equal to FT into CT minus 1 plus IT into CT. FT. What is FT? We multiply the old cell state by FT, forgetting the things which we decided to forget earlier. Okay. So then we add IT into CT. देखो वही same चीज वो बोल रहा है. CT is equal to FT into CT minus 1 plus IT into CT. So what is CT? CT is nothing but output you are getting after your tan H layer. ठीक है. So IT into CT plus FT into CT minus 1. ठीक है. So forget into CT minus 1. And then you are doing a point-wise operation. Point-wise operation, guys, कैसा होता है? इसको ये दो. Point-wise operation is nothing but, for example, let me say you have two vectors. So, and let me say the number over here is 4, 8, 7, or 9, or whatever, and over here you have, let's say 0, 1, 1, 0, 1. So we'll multiply 0, answer would be 0, 8 with 1, answer would be 8, 7 with 1, answer would be 7, 10 with 0, answer would be 0, 9 with 1, answer would be 9. So this is your point-wise operation. Okay. Point-wise operation. So do you notice after point-wise operation, the length of output vector is same? Dot product से confuse नहीं करना. In dot product, at the end you just used to have a single answer. So whether you are taking a dot product of 10 cross 10 or 20 cross 20, at the end you are having only one answer. याद आ रहा CNN में? We were using convolution, we are taking the dot product, but over here I'm taking the point-wise operation. Point-wise operation. So I'm taking a point-wise operation. बस अब तुम्हारा ये समझ खत्म हो गया. So FT into CT minus 1 plus IT into CT. So, and then this is the information which is flowing over here. So this information. Okay. So finally, we decide what we are going to output. The output will be based upon our solid state, but will be a filtered version. First, we run the sigmoid layer, which decide which part of the cell state we are going to output. Then we put this cell state through tanh. We push the values between -1 to +1 and multiply it by sigmoid grid so that we only output the parts we desired to. For the language model example, since we just saw a subject, it might want to output information relevant to the verb in case that's what is coming next. For example, it might output whether the subject is singular or plural so that we know what form of verb should be conjugated into. That's what follows next. ठीक है, बस यहाँ से खत्म हो जाता है. फिर उसके बाद वेरिएंट्स ऑफ लॉन्ग शॉर्ट टर्म मेमोरी स्टार्ट होता है. दैट वी डोंट नीड टू स्टडी. एक बार तुम लोग इसको वापस यहाँ से पढ़ो, देखो, है ना. जस्ट रीड इट वंस और ट्वाइस मोर एंड देन मैं एक बार से वापस एक्सप्लेन करने की कोशिश करता हूँ. सबके पास आर्टिकल है, राइट? प्लीज रीड इट. तुम लोग के सामने। अच्छा देखो एक चीज और देखो, लेट्स सी, मैंने एक स्क्रीनशॉट लगाया था। फर्स्ट ऑफ ऑल सी दिस थिंग, ओके, so what is this equation? This is CT is equal to FT into CT minus 1 plus IT into CT. ये सेम चीज है, CT is your current state is equal to FT forget into CT minus 1. So forget gate into CT minus 1. CT minus 1 is the memory state at time t minus 1. So FT into CT minus 1 indicates how much information you want to forget plus IT into CT. What is CT? CT represents your in the current state, sorry, at time t, how much information was passed through, and you are multiplying with your weights. So if he hasn't given the clear explanation, but देखो मैंने इसको यहाँ पे explain करके डाला, ठीक है? Try reading it. Do you notice it is the same equation? Same equation जो मैंने यहाँ पे लिखी है, जो यहाँ पे है. Now what is CT? CT is nothing but your current state. FT is your forget gate. CT minus 1 is cell state, or you can say cell state of previous cell state. IT is your input gate into CT. CT is portion of your current state. So this equation is used to update the current cell state. Okay, current state cell state. So in this current cell state, do you notice current cell state is a function of your forget also and input also. तो वही same statement जो मैंने बोला था ना, अगर कुछ नया सीखा नहीं, कुछ पुराना भूले नहीं, then it would be same. ठीक है? So FT into CT minus 1 tells how much information of the previous cell state should be forgotten, and IT into CT how much information of the current state should pass through. This is the base of LST. अगर ये क्वेश्चन समझ में आती है तो बस. This is the base of your equation. And now we already know how is FT getting, how you are calculating the FT. FT you are calculating when you are passing the HT minus 1 and XT. You concatenate and you pass it through your sigmoid. And IT into CT. CT is basically we multiply the old state FT, forgetting the things which we decide to forget earlier. Then we add IT into CT, portion. Basically, CT is nothing but portion of a new information. This is a new candidate's value scaled by how much we decide to update each state.
Hello, sir.
Yes, tell me.
If we are using our forget gate, the symbol of X is there, cross symbol. Does it mean that if any information is passing through that forget gate, that all information will be completely lost, or something, the part of the information will go through that?
You are talking about this cross?
Yeah, where tanh function is used.
Tanh तो forget gate में use नहीं होता. In forget gate, I am using sigmoid.
The next lines, right hand side, tanh.
Tanh, right?
Actually, I was trying to show you the different diagram, which is, I think, below. or above.
This one.
This one. The OT is passing through sigmoid function.
No. You are mixing two things. This is the output gate. This is the output gate. So forget memory state, memory gate, you can say forget gate, input gate, and output gate. See, don't get confused with output gate. Output gate is nothing but which I have already taught you. So after this thing, your CT, right? After this CT is nothing but your output. So this CT may again pass through your 10H. Okay? So basically, this CT may again pass through your 10H. So remember something like this. This is your XT, this is your HT minus 1, and then you have your HT, right? So this HT and CT are same. Okay? This HT and CT are same.
But a little difficult doubt is that in this diagram, IT is passing through the forget gate, right? CT and IT.
IT is the output from IT. This IT is output from your sigmoid.
Yes, so it is passing through the forget gate, cross gate. So is it forgetting?
Forget gate? No, it is not passing through. It is sigmoid is your forget, right? So it is out. You can say it is output from forget probably.
Okay. Right. Thanks.
Okay, and so this is basically this IT represents how much information you need to forget. Okay, and this CT represents the information, or I'll say current information, which has already passed from 10H. So it would be between your -1 to +1. Okay, can you notice one thing? इसको अगर मैं हटाऊं यहाँ पे, can you notice one thing? He has added a one symbol, something like this on CT, right? Yes. So this represents that it is this and CT. It means this and this information are not exactly same, because this might have been between your 0 to 1 or 0 to 10 or anything. It can be any number, but when you pass through 10H, it has marked it between your -1 to +1. Okay. And then you are performing this function over here. You are performing this function probably over here. And you are deciding how much to add. How much to add.
Can I scroll a little bit below?
Okay. See, so probably this brings into the theory portion. Variants of long short-term memory and all those things you do your self-study. Okay. फिर बहुत ज़्यादा complex हो जाएगा अपना explanation purpose. So now open your Jupyter notebook, or if you don't want to open your Jupyter notebook, that is also okay for time being. Basically, पहले मैं तुम लोगों को कुछ चीजें दिखाना चाहता हूँ. And then you rerun करोगे, then the auto into the bar direction. Okay, so I'm quickly pasting one small link. Just देखो उस link को देखो. So it is basically from Stanford University. Those researchers were done in Stanford University. Obviously, India तो कहीं stand नहीं करता in researches. ठीक है, तो हम लोग दूसरों का यूज करते रहते हैं. हो सकता है वहाँ पे इंडियंस ने काम किया हो. ठीक है, इसके लिए तुम बाद में प्राउड हो सकते हो. बट एक सेकंड नजर डाल. ठीक है, एंड आई विल यूज देयर कोड नाउ. Whatever. Okay. So let's see one thing. So देखो किसी ने नजर डाली इस पे. So global vectors for word representation, GLOBE. Try remembering this word, GLOBE. ठीक है. So GLOBE is an unsupervised learning algorithm for obtaining vector representation for words. So training is performed on aggregated global word co-occurrence statistics from a corpus, and resulting representation showcases this thing. So download the latest code, whatever. So तुम्हें कोड करने की जरूरत नहीं. I want to explain you something else. So pre-trained, this is your pre-trained model. Remember जैसे हमारे पास एक मॉडल था ना, text block या बेटा pre-trained था. So pre-trained word vector, thus data is made available under the public domain dedication and license. Whole text can be found at this. So it is in public domain. ठीक है, कुछ पैसे नहीं देना, कोई पायरेसी इशू नहीं, बिंदास यूज करो. लोगों ने रिसर्च करा और बाद में जनता की सेवा के लिए डाल दिया है. सो यू कैन रीड दैट विकिपीडिया ऑल्सो. सो एंड गीगावर्ड 5. सो बेसिकली इट हैज ट्रेन. इसको अगर हम देखें, लेट मी सी विकिपीडिया ऑफ दिस. नॉट फाउंड. ओके, वैसे अगर हम सिर्फ करें ग्लोब विकिपीडिया, ठीक है, तो ग्लोब का विकिपीडिया आएगा ऑब्वियसली. सो ग्लोब, अरे नहीं ये कुछ और है क्या. ग्लोब स्टैनफोर्ड. अच्छा, इसने सेम आर्टिकल कर दिया. हाँ, ये आएगा, ये आएगा. So I just want to show you one thing. सेम पहला आर्टिकल वही खुला. अच्छा चलो ठीक है, फिर हम यहीं से देख लेते हैं. सी, so pre-trained word. So basically it has been trained on how. I just want to show you how many training. Okay, so the globe model is trained on non-zero entities of global word-to-word occurrences. Size of training data मैं दिखाना चाह रहा हूँ. It has been trained on many million words. कोई जन जरा गूगल सर्च करेगा कितने वर्ड्स पे ट्रेन हुआ है. आई थिंक ऑलमोस्ट एंटायर रेडिट आर्टिकल्स इट हैज बीन ट्रेन. ग्लोब 1.4 200 वेक्टर्स 2. It would be in many millions, yes, but मैं बस दिखाना चाह रहा हूँ. It has been trained on many million words. So सब लोग ने वही same article ही refer किया. 6 billion words were trained हुआ, right? ठीक है. So basically they have randomly selected many articles and they have trained it. Okay. So the pre-trained vector, the data is made available in public domain dedication license, this thing. So Wikipedia gigawords. So यहाँ पे 6 billion tokens. Yeah, so it says 6 billion tokens. And then there are different versions of Globe, depending upon how many words they were trained. So probably every 2 year, 3 year, they are releasing a new version, right? So this Globe thing has been trained on a very large corpus of the data. And how did they train? They have used the nearest neighbor thing. Okay. So basically, for example, what I want to convey over here is, see, and the examples which they have taken also. So for example, uncle or man or sir and king, they have something in common. They all represent to a male candidate. Woman, queen, or whatever, mother, sister, they have something in common. They refer to a female one, right? So imagine for a machine. So we as a human being can say, okay, if a word mother comes, then also probably I'll refer to her, right? But if you do the same thing with machine, you pass thousands and thousands of articles, then probably it can draw a relation between them. Right? If you train it on a very huge corpus. In order to capture a qualitative way, the nuisance necessary to distinguish man from a woman, it is necessary for a model to associate more than a single word to a word pair. Natural and simple candidates, right? So basically they have already trained this model. So the Globe model is trained on non-zero entities. यहाँ पे इसने mention नहीं किया कितनों पे इसने train किया है, but if you read the it was trained on around 230K to 233K. So it means around 2.5 lakh words. बहुत हो गया. Due to local density of the related word that happen to have similar frequency. So if you train it on huge amount of data, then it can build slowly, it can build a relationship between uncle and man also, and man and sir also, and sir and king also. Okay? So why? Because I am going to use, so previously when we were building our NLP model, guys, जब हमने NLP model पहले build किया, I had used the concept of term document matrix, right? But this time in LSTM, what I will do, I will not use, there won't be any TDM. I would be using the concept of embeddings. Embedding means representing the word in vector format. Okay. So the similar words would be represented in a same vector. Representing the words in the vector format, embedded. And the same thing they have shown over here. Probably they are representing the word in the vector format. Okay. Each word would be represented by a number. अब इसको देखो कैसे करने जा रहा हूँ. I just want to show you one thing. So अगर मन रहा तुम लोग का तो मैं कोड पास ऑन कर दूंगा. You guys don't need to do any coding. So I have done some necessary import. And over here, what I'm doing is I'm using the Globe model, which was provided by the Stanford University. It is already there in public domain. So all this is a setup. Now what I'm doing is, so I'm saying embedding text. So in that text, I have passed the word data. Or let me say, if I pass the word king, then what would be the other matching words with the king? It is still running. So the matching word with the king can be king also, and it is giving the probability value also. So king is most closest to the king, then prince, then queen, then son, then brother, then monarch, then throne, then kingdom. अब जरा ध्यान से देखो, these words do have something to do with your king, right? Father, emperor, I don't know what is II, probably model still needs to be trained. Crown, reign, uncle, Henry, ruler, nephew, Edward, Charles, George, Frederick, cousin, death, Philip, duke, lord, grandson, sir, king, royal, grandfather, sultan, whatever, right? Suppose करो मैं यहाँ पे word pass करता हूँ queen. Let's see what are the matching words. Queen, princess, king, Elizabeth, royal, lady, Victoria. अब ये Elizabeth तो इसलिए आया because Stanford वालों ने पता है, तो उन्होंने अपने डॉक्यूमेंट ज्यादा पास कर दिए होंगे, ठीक है? So monarch, crown, prince, consort, majesty, daughter, Dutch, Diana, Beckham, right? So basically, embedding means the word is represented in vector format, right? And the words which are similar, probably they are shared in the same dimension or in the same vectors. So embeddings are generated. कोई और word बताओ किसके बारे में चेक करने का मन है? Let's talk about money. पैसा, हाँ? पैसे के मैचिंग क्या चीजें हैं? So it is still taking some time. So money, fund, cash, fund, paying, pay, paid, get, tax, financing, keep, million, much. So do you notice one thing? When you are, let me say you are writing an article. So whether the word fund comes or cash comes or pay comes, paid comes, probably it has something to do with your money itself. So article is talking related to some money or finance, million, much, keep, amount, raise, donation. हम लोग इंडियन से तो यहाँ पे क्रिकेट डाल के देख लेते हैं. वैसे आजकल मेरा मन हटा हुआ है क्रिकेट से. स्पेलिंग सही है? क्रिकेट, रग्बी, 2020, इंग्लैंड, इंडीज, क्रिकेटर्स, फुटबॉल, जीलैंड, आई थिंक न्यूजीलैंड बोलना चाह रहा होगा. मैचेस, बॉलिंग, WC, ऑस्ट्रेलिया, मैच, क्रिकेटर, टेस्ट, फर्स्ट क्लास, जिम्बाब्वे लीग, इंडिया आया है. बैट्समैन, नेटबॉल, विकेट, IPL भी आ गया. तो मतलब अच्छा ट्रेन किया. ठीक है. So basically, what are word embeddings? Let's see the definition of word embeddings. Word embedding techniques, फिर मैं तुम्हें कुछ ऐसी टेक्निक्स ही बता सकता हूँ जो मैंने मेरी खुद की बनाई हुई है. But word embeddings for the text, ठीक है. So the word embeddings are the type of word representation that allows word with similar meaning to have a similar representation. ठीक है. But to get this thing, so if you are designing your own technique, it will take many months because तुम्हें एक डेटा पे ट्रेन नहीं होगा. You may have to train it on a, I'll not say many months, but based upon your data, you can create your own thing also. But do you notice one thing? Do you notice one thing that this thing which I'm talking about, कहाँ गया? This thing which I'm talking about, it has nothing to, it can cover almost any topic. चाहे वो क्रिकेट हो, चाहे मनी हो, चाहे किंग हो, कोई और वर्ड लेके बताओ प्लीज. सोचो.
सर फूड.
फूड, फूड बोला उसने.
सर
चलो भाई फूड देखते हैं. फूड में क्या क्या आता है. कोई इंडियन डिश आता है? फूड, फूड सप्लाईज, प्रोडक्ट, मीट, सप्लाई, फैट, मेडिसिन, कॉफी, गुड, न्यूट्रिशन, मिल्क, हेल्थ, राइट. अब देखो ध्यान से, ऑल दीज वर्ड्स हैव समथिंग टू डू विद फूड. Some may have much to do, some may be very close, some may be little far. ठीक है. Drink, vegetable, yeah, this. यार फूड दिया तो ड्रिंक भी दे जाए. ड्रिंक से क्या आता है देखते हैं. ठीक है. ड्रिंक, बियर, ड्रिंक, लिकर, बॉटल, सोडा, बेवरेज, ईट. अब देखो almost everything has something to do with your things. ठीक है? है ना? और कोई वर्ड बताओ प्लीज. सपोज करो पिज्जा दे दिया, अब देखिए क्या आता है. पिज्जा, सैंडविच, ब्रेड, पिज्जास, बर्गर, स्नैक, टाको, पाई, चिकन. देख लो. So now this time the things have changed just slightly, right? So donut, pastry, snacks, government, fries. छोले भटूरे दे दे. अच्छा चलो फ्राइड राइस. देखें फ्राइड राइस पे कुछ आता है नहीं आता.
Sir,
हाँ.
can you put all your coding on the chat?
First you try understanding it, then I'll put.
Okay, sir.
So I think उसने स्पेस शेयर नहीं किया. क्या प्रॉब्लम? Okay, so I think उस वर्ड के लिए वो इशू दे रहा है, वो शायद वर्ड से मिल नहीं रहा. फ्राइज.
छोले कुलचे.
क्या?
छोले कुलचे.
छोले कुलचे. हाँ. फ्राइज, बर्गर, हैमबर्गर, फ्राइड राइस. ठीक है. सो आई थिंक छोले कुलचे डाल के देख सकते हैं अगर तुम्हें डालना है, बट शायद ट्रेन नहीं होगा मॉडल, है ना. अब छोले कुलचे की स्पेलिंग बताओ. छोले कुलचे. बात लो, तुम लोग लाइफ में क्या क्या करा रहा हूँ ऐसा. ठीक है. सो नॉर्मलाइजिंग. सो नो मैचिंग वर्ड फाउंड. ठीक है. कहाँ तुम यार छोले कुलचे में उलझे हुए. ठीक है. बर्गर. ठीक है. ठीक है. सो लेट मी से राइस. देखिए राइस पे तो ट्रेन होना चाहिए ना. राइस पे नहीं मिला था. मिलेगा. So rice, wheat, corn, grain, food, right? Okay. So basically what I wanted to show is the same thing. Let's come back over here, embeddings. So these are, so now do you notice this one thing over here, that these embeddings, this data is trained on across the domain. So whether you put a word related to your food or whether related to your geopolitical things or any other thing, it can give you the answers because it has been trained on many million articles and millions of words. But many a times, I am not focused on such a big data set. I may just want to build my embedding based upon our own requirement. So for example, if I'm trying to do sentiment analysis on Amazon data set, then probably I don't need the input related to your sports, right? I don't need input related to your sports. If I'm doing a sentiment analysis on, let me say, restaurants, whether the feedback was good or not, I don't need anything related to your politics or related to your sports. I can create my customized embeddings. But what are embeddings? So word embeddings are type of word representation that allows word with similar meaning to have a similar representation. They are distributed representation for text that is perhaps one of the key gateways for impressive performance of deep learning methods. Okay? So instead of using TDM, we use our embeddings. In this post, we will discover whatever. Okay? So there are different methods. So what are word embedding, word embedding algorithm? So how to create a word embedding, I'm going to cover it up in the coding part. Okay? But what is word embedding? Itna cheez yaad rakho. Word embeddings are type of word representation that allows words with similar meaning to have similar representation. Kaise create karta hai word embeddings? Very simple. Very simple. The way your mind creates the way your mind works, similarly it will work. So for example, your mind understands that there is some similarity between your king, man, prince, or let me say dad or godfather or whatever, right? There is some similarity between these words. Right? There is some similarity between these words. So there might be some similarity between your hero also and some similarity between your villain also. Probably they are very much similar if you talk in terms of antonyms, right? So Now, since you have been reading the English language from your childhood, your brain has automatically built a similarity. But if I pass several thousand sentences, then slowly it will also create a embedding. No? It will also create a embedding. So the same way. Okay. So let's do one thing. Let's build our LSTM model. And this code I'm not putting on the chat. पहले model build कर लो. ये code तो खेलने के लिए है. ठीक है ना? ठीक है. First, let's build our LSTM model on a ham and spam. Okay. So previously we have built the model using what? NLP. This bar, let's build a model using our LSTMs, and then probably I'll put it over this code. So remember glove, and then there are many other ways also. अच्छा, एक चीज और मैं डिस्कस कर लेता हूँ. Again, just for your more knowledge. मैं तुम लोग को एक चीज और दिखाना चाह रहा हूँ. If I'm able to execute it, otherwise we'll move towards that. See, one more thing. So please write down two lines which I'm going to tell you. So and these two lines are for your interview purposes. अगर कोई पूछता है, so normally इतना सब पढ़ने के बाद कभी कभी कैसे होता है, इंसान छोटा क्वेश्चन आंसर नहीं कर पाता. सो इफ समवन आस्क्स यू, डू यू नो अबाउट एनी प्री ट्रेन्ड मॉडल और प्री ट्रेन्ड टेक्निक्स फॉर जनरेटिंग एम्बेडिंग्स? ओके, अगर क्वेश्चन आता है एम्बेडिंग्स क्या होते हैं, सो यू शुड बी एबल टू आंसर. प्री ट्रेन्ड एम्बेडिंग्स जनरेट करने के लिए देयर आर टू बेस्ट थिंग. सी देयर आर मेनी वेज और मेनी प्री ट्रेन्ड मॉडल्स पीपल हैव written, right? But the best two are your, एक तो वही है GloVe, which is by your Stanford University. But यूनिवर्सिटी चाहे कितनी बड़ी हो, गूगल के आगे तो छोटी ही है, ठीक है. Word2Vec is by your Google. ठीक है, ये दो वर्ड याद रखो. Word2Vec is again the pre-trained model to generate your embeddings, and GloVe, and then there can be many. You can create your own embeddings, but these two things are heavily used in industry. If you are working on a data which is not specific to any domain, it can consist of any domain, and you want to use a pre-trained model, pre-trained technique to generate the embeddings, then GloVe is from your Stanford, and Word2Vector is from your Google. And they both are in open domain, open source domain. Okay, so please try remembering these two words, GloVe and Word2Vec. ठीक है, अगर कोई पूछ ही लेता है तो you should be ready with the answer. ठीक है, I am trying to generate Word2Vec, but थोड़ा सा टाइम लगता हुआ दिख रहा है. I think I have run it. ये भी बड़ी सही चीज है. हाँ अच्छा, let me share my screen once more. See, now what I'm doing is word embedding by Word2Vec designed by Google. So code word and the just देखो. So for example, woman and king, or let me say man and king डाल देते हैं. So what is similarity between man and king? So yeah, इसको छोड़ दो. Let me talk about man. So I just want to see the top 20, or let me say king. So king की similarities हो सकती हैं prince, queen, emperor, kings, regent, throne, pop, Constantine, argon. Suppose if I say food, it can be meat, milk, dairy, food, livestock, vegetable. So मैंने यहाँ पे एक कोड डाला है, टॉप 20 डाला है ना. सपोज को टॉप 100 डाल देता हूँ मैं. ओके, सो अब यहाँ पे आता है प्रिंस, क्वीन, एम्परर, किंग, रीजेंट, थ्रोन, कैसल, स्कॉटलैंड. देखो कितने सारे वर्ड्स वो दे रहा है. नेपोलियन तक दे दिया उसने, वॉइसरॉय. ठीक है, सो नाउ दीज एम्बेडिंग्स आर जनरेटेड फ्रॉम Word2Vec, which is from your Google. Again pre-trained कैसे करा मैंने, पहले इसको डाउनलोड करा, फिर उसका एक कॉर्पस जनरेट किया. सो कोड इज ऑलरेडी अवेलेबल इन ओपन डोमेन. दिस इज नॉट माय कोड, सो इसके लिए मेरे को कुछ श्रेय नहीं जाता है. ऑलरेडी प्री ट्रेन मॉडल, आई एम जस्ट रनिंग. ठीक है, आई एम जस्ट रनिंग. ठीक है, तो मैंने इसमें कुछ कमाल नहीं किया. सपोज करो वीट, इन दिस क्या प्रॉब्लम आ गई भाई कि वीट इज नॉट प्रेजेंट. मैंने डब्ल्यू कैपिटल ले लिया, सब कुछ स्मॉल होगा उसमें. barley, vegetable, potatoes, maize, citrus, beef, cereal, shrimp, corn and seafood. Seafood से याद है, चलो salmon. Tuna, freshwater, trout, fish, shrimp, cattle, shellfish, mammoth, whale, prawn. देख लो कितना सही ट्रेन किया लोग ने. सी, Caspian Sea, Adriatic, Danube, Strait, waters, Mediterranean, Aral Basin, ocean. अब एक अच्छा सी दिया तो ये आया, अगर मैं ओशन दूं तो क्या आता है? आर्टिक बेसन, एंडीज, टेक्टोनिक, कुछ नहीं। अगर इंडियन ओशन पैसिफिक एच भी नहीं है, ठीक है। एनीवे ओके, लेट्स सी इफ आई गिव इंडिया तो क्या आता है? कुछ आता है? पाकिस्तान, इंडोनेशिया, बांग्लादेश, चाइना, बंगाल, टर्की, पंजाब, अफगानिस्तान। तो काफी कुछ चीजें आती हैं, है ना। सो ओवर हियर मैंने सिर्फ 10 लिया है, तुम चाहो तो इसको आगे भी दे सकते हो, राइट। सो इट हैज बीन ट्रेन्ड हेविली एंड सपोज अगेन if I do a Google search word to vec, let's see on how much data it was trained word to vec. So then use a natural person corpus of the text from the large corpus of the text. कितने अच्छा लार्ज कॉर्पस ऑफ द टेक्स्ट, टेक्स्ट साइज इसने मेंशन नहीं करा है, मेंशन करा होगा कहीं पे। ओके, वर्ड वैक डेटा साइज। I think they have trained it on millions and millions of words पे train करा है उन्होंने। वर्ड टू वर्क विकिपीडिया, विकिपीडिया तो हमने अभी देखा था, राइट। उसमें जरा एक बार सर्च करो, देखो कहीं पर उन्होंने मेंशन किया गया। सो इट इज ट्रेन ऑन मेनी मिलियन वर्ड्स।
Sir, there is the same question. What is a good embedding size above that?
What is the?
What is the window size in word to vec? We can find answers there.
Window size? What do you mean by window size?
The sub questions were given there before the article.
No, I'm not getting your question. What do you mean by window size?
No, I'm telling when we search that, the small little questions were given one after another.
Okay. Coding
below Wikipedia. No, in the search, below Wikipedia, in the search section. These people ask.
What is the total ideal size of अच्छा? ठीक है, तो अराउंड 250 GB डेटा नहीं, ये शायद आंसर नहीं करता। 10 मिलियन पे ट्रेन किया है। ओके ठीक है, वो लिंक डालो जरा जहाँ पे लिखा हुआ है, देखें कितना जेन्युइन है वो लिंक। वैसे मिलियंस एंड मिलियंस ऑफ वर्ड्स पे मैंने इसका आर्टिकल पढ़ा हुआ है। एंड भेजा, एंड ऑब्वियसली आई होप किसी के मन में ये तो नहीं आ रहा है कैन आई ट्रेन इट द सेम द वे गूगल इज। आंसर इज ऑब्वियसली नो, राइट। तुम्हारे पास ना उतना बड़ा सॉफ्टवेयर है, ये विकिपीडिया तो पहले भी था हमारे पास वर्ड टू वर्ड। यहाँ पे कहाँ पे लिखा हुआ है? कहीं पे लिखा हुआ है? कहाँ पे लिखा हुआ है एग्जैक्टली? हाँ, इट इज ट्रेन ऑन मोर देन 10 मिलियन वर्ड्स। देखो ठीक है, मोर देन 10 मिलियन वर्ड्स। 10 मिलियन मीन्स 1 करोड़, ठीक है। 1 करोड़ से ज्यादा वर्ड पे ट्रेन किया हुआ है, ठीक है। व्हेन इट इज ट्रेन्ड मीडियम टू द लार्ज कॉर्पस, उसको भी वो मीडियम बोलता है, ठीक है। एंड ये आर्टिकल कब लिखा गया था? आई डोंट नो। सो विद टाइम प्रॉब्ली दे कीप ऑन इम्प्रूविंग, ठीक है। विद टाइम दे कीप ऑन इम्प्रूविंग, बट 1 करोड़ वर्ड इज अ वेरी लार्ज कॉर्पस। प्रॉब्ली इतने वर्ड शायद इंग्लिश लैंग्वेज में ना हो, अक्रॉस द लैंग्वेजेस इट माइट हैव टेकन, ठीक है। And so after this word to vec, what has happened? So this after this word to vec, then Google has come to this BERT, or you can say robot. So BERT language model, BERT size. So जो मैंने तुम लोगों को बताया था ना, जिस पे आजकल मैं काम कर रहा हूँ, so BERT data. So ये तो इतना heavy है कि you just can't imagine. So data on which BERT is trained. So all these are pre-trained models companies have with lot of. So 3.3 billion words from entire Wikipedia लिया है. Can you imagine how many Wikipedias would be there? हर एक word पे एक Wikipedia है, right? Entire Wikipedia पे train किया है उसने. 3.3 billion words. 1 billion is 100 crore. So around 330 crore words पे train किया है उसने, right? And then since the data is so much, probably it can easily build the relation कि इंडिया पाकिस्तान में क्या रिलेशन है और इंडिया और चाइना में क्या रिलेशन है, and what is the relation between king and queen. So all these words में what is the relation, right? ठीक है. So but then obviously all this BERT robot I cannot discuss with you guys. ठीक है, but मैंने बता दिया, अगर तुम लोग को चाहिए होगा तो कोड मैं कभी दे दूंगा. BERT का कोड ऑलरेडी है हमारे पास. But as of now let's focus on our building LSTM model on what? Spam and ham. ठीक है ना. Model building will not take much time. अगर थ्योरी पता है तो this would be quite easy. क्योंकि मैं जो तुम्हें कोड दूंगा it would be generic, simple, can be extrapolated to any other thing. So the way I always do it. File read कर लो guys सब लोग, and then let's get started. So give me also some time to read the file and then let's. Okay, see, everyone please stop over here and just have a look. So can I say line number 3 is clear? I am reading the file and selecting the first and the second column. And then you rename the column V1 and V2, label and V2 as messages. Then ham and spam. You mark ham as 1 and spam as 0. Okay, so this is the basic data cleaning which I am doing. Basic data cleaning. And at the end, your data looks something like this. Messages.head. So it should have 2 columns, label and message. In label, you have zeros and ones. In message, obviously, you have the entire text. यहाँ तक सब लोग please करो data cleaning part. And then we'll move it.
So can you scroll up a little bit?
I can, but why do you want me to scroll up? This data cleaning part, I'm expecting people will do very fast on their own because this code would be already with you. Till this point, there is nothing like LSTM I have introduced. This is just simple data cleaning. Okay. Okay, take your time, but make sure everyone gets the data in this format. Label आ गया, message आ गया, and it looks something like this. If you already have the code, and then if I think कि सब लोग सही डायरेक्शन में जा रहे हैं, तो मेरा मन करेगा तो अपना बर्ड Let's do one more thing, though it is not that much needed, but if you want, you can do it. Let's do one thing. So what I'll do is I'll say messages. Messages is the name of my data frame. Message equal to messages dot message dot str dot lower. If you want to convert everything into lowercase, right? So that two words have the. Remember, Python is case sensitive. So two words which are same, but if their fonts are different, or I'll say if they, I'll not say font, but if their case is different, probably they may be taken as a different words. So convert everything into the lower case. सबको समझता है ना lower case में क्यों convert करना है, right ना? That is a healthy practice. बस अब कुछ नहीं, मॉडल बिल्ड हो गया. Okay, so this time you don't need to remove these stop words. सब लोग please एक note करो. While building your embedding models, I don't remove the stop words. Probably even if I don't convert into lowercase, it will still give a good decent result. Okay, but if you convert it, it's okay. No need to remove stop word. No need to remove any punctuations. कुछ मत करो, वो अपने आप handle कर लेगा. It is like your human brain. It will read many documents and it will understand. Okay, no need to remove any stop word punctuation. But if you want, you can remove it. But it is not needed and not advisable also most of the time. Okay. Sampling कर लें. First of all, please confirm.
Sir, we have to convert into lowercase, na? Sir?
Lowercase में convert कर लीजिए. Convert into lowercase. So at line number 7, Vaishnavi, I have converted into lowercase. Convert into lowercase. जिसका मन नहीं है मत करना. Later on, you comment out this line and run it once more. You may not see much changes. Okay, it may still give a decent model because it can build the relationship. It can build that capital KING and small KING are probably same.
Okay, sir. Done, sir.
Done. Done. Now let's go ahead for our sampling. So I'll say from sklearn dot model selection. Import train test split. So messages underscore train, messages underscore test equal to train test split. Messages train equal to messages train dot ilog. ट्रेन एक्स कर लेना. एक काम करता है ना, ट्रेन पूरा लिख लेता है. अदरवाइज वो मेरा ही कोई कंफ्यूज कर रहा है. सो ट्रेन में क्या चीज, एक्स में क्या आ जाएगा? कैन आई से x would be nothing but this and this, correct? And train y would be nothing but 0. तो कॉपी करो, यहाँ जहाँ जहाँ ट्रेन है वहां टेस्ट करो. एक नजर डाल लेते हैं सब कुछ सही है कि नहीं. Messages train x not wrong. Okay, I did not do that. हाँ ठीक है, make sense. Train x and train y. Done. अच्छा now ठीक है. Now till this point everything is same. There is nothing like I have introduced anything different. You guys are already familiar with this thing. Now if I do something, you will notice the answer. It is zeros and 1. Right? And if I run the type function on this, let's not say type, but let me shape 1356. 1356. Okay. Now what I'll do is I'll convert it into categories. Message train y. So whether it is test y or train y, it would be in categories. Train y. अब यहाँ पे एक line आके डालो. So run this line from tensorflow.keras.utils import to categorical, right? So what I'll say is to categorical. And tell me what are the changes you notice.
Can you send that code, sir, from TensorFlow to all libraries?
क्या चेंज आया है एरे में आया है सो डू यू नोटिस वन थिंग दिस टाइम the shape has become 2-dimensional and if you check this thing can you notice it is 0 1 0 1 अच्छा let me do one thing मैं ना एक चीज और करता हूँ and so this is let me say before converting this to अच्छा एनडी एरे में कन्वर्ट कर दिया ना इसने ठीक है बाबा एरे में कन्वर्ट किया ना तो अरे ठीक है अच्छा ना ठीक ठीक सब लोग अब प्लीज ध्यान दो यहाँ पे आई जस्ट रिपीट इट वंस so this at line number 27 is before converting to categorical so you have 1 1 1 and then you have 0 1 1 1 0 1 1 1 at line number 28 I have converted them to categorical and then I'm seeing the top 10 records so do you notice it is 0 1 why 0 1 because the first record is 1 then again for the first 4 records do you notice it is 0 1 0 1 but the fifth record is 0 and that is why do you notice 1 comma 0 do you remember the concept of one hot encoding one hot encoding याद आ रहा है नहीं आ रहा है नहीं याद आ रहा है dummy variable categorization yes one hot encoding so for example let me say you have something like this you have a column which contains name of the animal let's say cat dog and elephant Okay. When you one hot encoding, then it will create 3 columns: cat, dog, and elephant. Since the first record was cat, it would be taken as 100. Second was dog, it would be taken as, और ये हो जाएगा, सपोज करो नेक्स्ट वाला फिर से डॉग आ गया तो ये क्या हो जाएगा, बराबर. So the same thing has been done over here. Same thing has been done over here. अब बताओ लोगों को समझ में आया? What have I achieved using my categorical? ठीक है. So your ham and spam, which were initially marked as 0 and 1, now they are represented in 2 dimension. You have added 2 columns to your target variable. ये शायद पहला change आता हुआ दिख रहा था, ठीक है ना? Can I say this line is line number 28 is clear to everyone? ठीक है. One hot encoding और dummy variable categorization. अब मैं थोड़ा सा स्लो कोडिंग करता हूँ, ठीक है. हेलो, प्लीज.
आम्ही दोनच लाईन केले रे. किती मेहनत करते कोणी अप्लाय केलं मग तू नाही केलं का आपल्या आठ लाख आले ठेवतात 2 वर्ष दोन काय राहावं लागेल. 8 लाख देख तू ही देख जुगाड़ इधर तो ना.
So let's do our coding. So maximum number of words, and then I'll say basically अगर मैं चाहूँ तो सारा कोड कॉपी पेस्ट भी कर सकता हूँ, but still I'm writing it. I'm taking some effort so that. But you later on, what you can do is you can just copy paste it. So what is maximum number of words? So maximum number of words, sequence length, embedding size. First of all these are hyperparameters. You can change them. All these are hyperparameters. Okay. So sequence maximum number of words 10,000 means how many words or how many unique words, probably you can say, you want to consider from entire corpus, which is your full document. Okay. Now, everyone again stop your coding and have a look over here. So, we train our model on our trained data. We train a model on our trained data. So, sorry, यहाँ पे train डालना चाहिए था मुझको. So my trained data has 5,420 records, you can say, or I can say my model or my trained data has 5,420 documents. Remember, corpus is nothing but collection of document. So in this document, there might be many words, but I will consider 10,000 words. Okay? So how many unique words you want to consider from your entire corpus? Now you can change this 10,000 depending upon if your data is very big and it is related to many topics. Over here, I am dealing only with my one particular domain, right? Whether email is ham or spam. Okay? So sequence length is 50. So sequence length is 50 means, remember, you have the basically data would be passed in batches of 50. You will take 50 words of batches. Embedding size 100. So for each word, you will create a vector representation of 100 words. So abhi dekha tha na hum log ne? So for example, when I gave the king, it gave 100 words for king. So the same thing. How many words are similar to a particular word? So I'm saying embedding size as 100. Embedding size as 100. Now these are the hyperparameters.
Sir, what is sequence length?
Sequence length of 50. Okay. See, let me do one thing. Let me go to the paint window. Okay, let me discuss all the three things. So I have taken 10,000. 10,000, it would be maximum number of words. Okay, maximum number of words. Okay, sequence length. Sequence length, how much I have given? I have taken sequence 50. Length as 50. Again, this is a hyperparameter. So remember, the words are passed in vector format. Suppose you have a document. Suppose you have a document. Okay, and this is your first word. And this is your 500th word. Okay. So sequence length of 50 means you will take the first 50 word and pass it through your as a vector format. So 1, 2, 3, and it goes till 50. Network se pass karna hai na? So the sequence length, you don't want to pass one word at a time. You want to pass 50 words at a time. So every time you are passing the 50 words sequence length. Okay. And then what is the next one? Embedding size. Now what is embedding size? Suppose you have a word king. You have this word is your original word. You are generating the embedding size for king. So which is the nearest thing to the king? Let me say the king itself, or let me say the nearest to the king is your prince. Okay, and the similarity between king and prince is 0.9. Okay, so it would be, and then similarly you have a something like queen, and then you have, let's say, son. You have, let's say, kingdom. So vector represents this is your embedding size. For each word, how many embeddings you are generating? Remember, अभी morning में हम लोग ने जो coding करा था, जब मैंने इंडिया दिया तो पाकिस्तान or whatever came, right? Nearest. So embedding means how many embedders you have created, the matching words, right? Vaishnavi, is it clear? No answer from her. Okay. Okay. So remember when we were using our NLP also TDM, we have converted the word to the numbers tokenizer. याद आता है? So over here also, this time I am using the Keras tokenizer. ठीक है? And then paired sequencing. कोई problem?
सर ये पैड सीक्वेंस कर देना।
Pardon?
सर ये पैड सीक्वेंस कैसे यूज होगा?
I'll tell you what. So see, do you remember the concept of padding in CNN? Concept of padding in CNN, the same concept I would be using over here. So for it's not necessary that for each word you might be able to generate the 100 embeddings. So the padding would be added, right? So अभी दिखाता हूँ मैं तुम्हें कोड में कैसे वो होता है. What is the impact? Guys, सब लोग please एक second यहाँ पे stop your coding, whatever you're doing, and check this thing. So what I've done is, do you notice at line number 82, what I have done is I have commented the line pad sequencing. And so basically for trained data, what I have done, I am not using the padding. But for the test, I am using the padding. अब देखो difference देखो क्या आता है. So when you select any record from the trained data, do you notice? So for example, what I have done, I have set 10,000 over here. It means it will select 10,000 words. And for each word, it will assign one number. It means each word, it will assign a number. But out of these 10,000 words, there might be only few words which may be present in a one record. ऐसा जरूरी तो नहीं ना कि सारे 10,000 वर्ड each and every record में present हो, right? So out of 10,000 words, maybe only some for 20 words or 30 words or 40 words are present, right? So basically at message train X5. So in record number 5, out of 10,000 words, only these many words are present. Okay? And I have not done the padding. So if you don't do the padding, this can keep on changing. So therefore, in X5, how many words are present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But if I select some another record, the number of words have changed. Suppose if I take record number 234, the number of words are many. So the size will not remain same, and this will create a problem. But if you notice in text X, I have done the padding. अब तुम देखो किसी का भी तुम साइज ले लो, उसका साइज हमेशा 50 फिक्स होके ही आएगा. Suppose if I take a record number, देखो, so it is adding extra zeros. It is adding extra zeros. ठीक है? That is the advantage of, or that is the usage of padding. ठीक है? Suppose if I take record number 100. Okay. Are you getting the point? That is why we do the padding. So to bring each embedding at the same length. So इसको क्या करूँगा मैं starting से रन करता हूँ. Otherwise ये बहुत issue create करता है. बस अब क्या है? Unexpected and passing. अच्छा. Input dimension, maximum input length. Input length, not sequence length. Actually, maximum words we should get. Init one model dot add embedding एक लाइन में डालूं तो चलेगा, बस ऐसा नहीं होना चाहिए। यार ये ऊपर वाले में क्यों प्रॉब्लम आ रहा है, नीचे वाले में क्या क्यों नहीं आ रहा है? वही सेम कोड तो लिखा है मैंने, कुछ डिफरेंट है क्या? कोई गलती करी क्या? इनपुट आउट, ये आउटपुट की स्पेलिंग यहाँ पे गलत रखी हुई है। कभी कभी ना अपनी गलतियां निकालना और मुश्किल हो जाता है। लेट मी डू वन थिंग।
So line number 149 is padding.
लाइन नंबर 149? नो,
Where is the padding?
पैडिंग इज ओवर हियर ना, पैड सीक्वेंस।
Okay, sir. Okay, sir.
So basically I have created the network. Then what I'll do is I'll compile it. I'll say model dot add, and this time I'll say LSTM. Let me add the file. Model dot dense add and let me say application is soft. इसको तो एडम को तो ऊपर इंपोर्ट कर लेते हैं। Model dot fit, and then let me say train x, train y equal to 5. Let me say validation equal to 0.1. Model starts running.
Sir, can you show me the importing Adam?
Importing Adam is already discussed, so I'm expecting people already have this thing.
Sir, please send that entire code, no? Importing
No,
Adam
I will
here.
not send. Code karo pehle.
I have
Request-
already written the entire code, sir. But that the
Request,
two lines
request
are
denied. Request denied. Try solving the error. Okay, I cannot afford to make everyone so lazy. चाहता तो मैं भी पूरा कोड कॉपी पेस्ट ही कर देता था, मेरे पास तो ऑलरेडी है, बट फिर भी इतना एफर्ट लिया है. सो योर रिक्वेस्ट इज ब्लैंकली डिनाइड. ठीक है, प्लीज कोड इट, ट्राई फाइंडिंग एरर। फिर भी नहीं होगा, देन आई विल। जब कोड करोगे तभी कंसेप्ट याद रहेगा।
So I have written the entire code, but those two code missing, the libraries,
Which library?
the above GRU something, those 5 lines of this green.
Then try
That
importing
is,
it.
4 lines I have been written, only 2-3 lines are missing. That's what I want. Can
Write
you
it.
please put it in chat?
कौन सी लाइन तुम्हें चाहिए? तुम्हें कोड करने में प्रॉब्लम क्या है, पहले ये बताओ।
I have written the entire code, but I think this then simple RNN GRU LSTM embedding is missing in my code.
Okay, so you don't need GRU. I am not building GRU model. और बताओ, simple RNN you don't need. आप बताओ, ठीक है?
From care,
Hence LSTM embedding, ठीक है? You import your dense, you import your LSTM, you import your embedding. Sequential, Adam you already know, categorical you already. Acha, guys, now everyone please have a look. Please have a look. Everyone please have a look. Let me try explaining it. So can I say line number 154 is automatically clear to you? There is no change the way you run your fit function, right? Messages train X, train Y, the number of epochs or whatever you want to take. Model dot compile, same thing. Adam, loss categorical matrix accuracy. Learning rate, we have already discussed learning rate. Now, over here at line number 145, I am creating the network. Remember, we need to initialize the network. So input dimension, I am saying maximum number of words. So maximum number of words is 10,000, sequence length, embedding size. Can someone tell me what is this LSTM5? देखो यहाँ पे. So while explaining, I have said that your LSTM or your networks look something like this, right? So this is your XT, and then this is your HT minus 1, and this is your HT. Over here, you are having one neuron, but instead of having one neuron, I am having 5 neurons. Okay? Rest everything is same. And with that, I assume people understand that instead of 5, you can give 4 also, you can give anything else also. Don't try to give very high number, but there is no as such no limitation. If you want, you can give 50 also, 20 also, but 5 le liya hai maine. Then what is this to map to? Number of levels in your Y variable. Remember, you have ham and spam, and activation is softmax. Learning rate में already पता है, fit function लगा दिया, खत्म. And then you do your prediction. So let me say predict values equal to model dot predict, and in predict, let me say I want to do the prediction on my what? On my test X. अच्छा, again everyone please stop. Just एक second यहाँ पे देखो. So this time when I'm doing the prediction, do you notice that I am getting prediction in probabilities? Remember, my target variable was having 2 levels. I have done the categorical correct. So my target variable was having 2 columns, 0 and 1. So this time I am getting output in probabilities. So for each and every record, I get 2 values. If you add both of them, then remember, answer would be 1. Correct? कहीं कहीं पे राउंड ऑफ करने पे शायद आंसर हल्का सा ऊपर नीचे जाता हुआ दिख रहा है, बट देन इट इज 1 ओनली. ठीक है. नाउ if I talk about this first record, where should it be marked? Should it be marked under 0 or should it be marked under 1? Under 1. Why? Because probability of 1 is more. तुम बताओ, let me call out a name. जिसने भी question पूछा था, क्या नाम है उसका? Ubaid. You tell me, what about this record? Should it be marked under your class 0 or class 1? Ubaid, this question is to you. This record should be marked under your class 0 or class 1? Answer नहीं कर रहा है. Class? Dhruv, you tell me.
0.
Class 0. Why? Because probability for class 0 is more. It is 0.91. So जो पहला column class 0 को represent कर रहा है ना, second column is representing your class 1. That's the standard thing. What about this one? ये बताओ. This should be marked under your class 1.
1.
Class 1, yes. Now, only thing is over here is to build the confusion matrix. To build the confusion matrix, probabilities should be converted to zeros and 1. ठीक है ना? ये तुम लोग करके देखो कैसे कन्वर्ट करोगे. np.arg max वैसे कर देना. अगर मैं इसको बोलूं np.arg max and if I say spread value comma x is equal to, okay, prediction and classes. एंड अब तो कंफ्यूजन मैट्रिक्स बनाने में तुम लोग को करोड़ों साल का एक्सपीरियंस है. ठीक है, भले समझने का ना हो लेकिन क्रिएट करने का तो है. ठीक है, कंफ्यूजन मैट्रिक्स लिया एंड देन pass your actual. From where would I get my actual values? Actual values I'll get from my test y. गजब का मॉडल आया है. ठीक है. So guys, please do your coding and put your confusion matrix on the chat. My job is done. अब तुम सबकी जनता की भलाई के लिए अब थोड़ा सा कोड में चैट पर डाल दे रहा हूँ. नहीं, आई एम जस्ट वेटिंग फॉर 5 minutes and then probably so I'm trying to put huge amount of code in the single window if it helps you or not. कहाँ तक कर लिया तुम लोग ने? कंपाइल तक हो गया? जिसका होता जाएगा they will start putting the confusion matrix on the chat window please. किसी 5 का भी हो गया उसके बाद पूरी क्लास का हो जाएगा. यहाँ वहाँ से एक दूसरे से
Oh, I'm getting an error. Can you help me? I put it on the chat.
value array input of layer sequential 3 is compatible with layer expected shape. This at which line you are getting error while running which code?
Model fit, sir, 154.
Do one thing. You run your code from the top, from the point where you have read the file. वहां से run करते हुए आइए please.
So same errors happening. So same errors happening.
क्यों हो रही error? See, to solve your error, I need to see your code. And see, basically somewhere you have made a mistake and or you have missed some parameter. While running your fit function, you are getting an error.
Yes, sir.
Okay, so I'll tell you some things which you check. First of all, check your message string Y. Is it categorical? Check the length of your message string. Is the length matches with your messages string X? The number of records are the same. Okay. Do all these checks because if the problem is coming from fit, it means so while compilation you did not get the error.
No, sir.
No, right. So then probably there is the error in your data, the way you have converted. So check your data. Check your data means मैसेज ट्रेन एक्स को रन करके देखोगे देखो क्या है ऐसा डेटा है सिमिलरली ट्रेन वाई इज इट समथिंग लाइक दिस एंड लेट मी नो
Okay. Yes, sir. It's exactly like that only.
exactly like that then you check this thing what have you given over here in embedding maximum number of words sequence length and embedding size I hope in front of input length you have not given maximum number of words कहीं तो गलती है अगर वहां नहीं तो कहीं और होगी
The embedding lines and are much below maximum number of words are the
So
much
you're
below.
right. So I made a mistake with the sequence length. I wrote max number of words instead.
Hmm.
change that thing and then you put in the top
Yes, sir. It's done. Thank you.
so are you able to execute the fit function
Yes, sir.
जिसका फिट हो जाएगा जल्दी से कंफ्यूजन मैट्रिक्स रख के मेरे को चैट विंडो पे दिखाओ प्लीज कितना टाइम पास करते हो तुम लोग
I put it on, sir.
देखो उसने कर भी लिया so seems to be quite good one huh?
embedding
Okay, so Siddharth has also messaged me. So Dhruv, Siddharth, just by seeing your confusion matrix or my matrix, it gives a very good idea that accuracy is very high, but still find the accuracy in numbers. देखो 99.99 है, 98 है, कितना है?
Okay, sir.
जो लोग क्लास में उनका क्या चल रहा है? कल्पेश, ओके, ठीक है, fair enough. So accuracy seems to be quite high, right? 98, 99 के आसपास. नहीं 99 के आसपास जा रही होगी भाई. कितने कम तो एरर्स हैं. सपोज करो मैं एक टेबल में स्टोर कर लेता हूँ. नाइनटी 99.48 बहुत ही हाई एक्यूरेसी है. So Prathamesh, Kalpesh, Siddharth and Dhruv.
99.
Very high accuracy. Vaishnavi, what about you? क्या आंसर नहीं आया? श्रद्धा, शुभम,
Sir, I'm
भूपेश.
doing, sir. Actually, due to network issue, I'm facing some. Doing, sir.
Doing Shreyas.
99.
Fair enough. So people are getting high accuracy. ठीक है. So now, what do you need to do for your self practices? मैंने और कौन कौन से डेटा सेट्स दिए हैं? ट्रिप एडवाइजर दिया है, ठीक है. So build a model on TripAdvisor, build the model on Amazon food reviews. पहले TripAdvisor पे build करना, ठीक है ना. Try building a model on TripAdvisor, Amazon food review. Model है then यही वाला model, LSTM models. Okay, that is for your self practice. ठीक है. If you think that model is not able to handle this much big amount of data, then try reducing the data, guys. ठीक है ना. Try reducing the data. Train data reduce कर देना probably. Yes, it is a hyperparameter. If you want, you can change it. Change करके देखो. 10,000 से 11 कर लो या 9 कर लो, right? Change sequence length, change embedding size. Okay. So I'm getting some more answers. Vaishnavi, Karthik. Okay, so fair enough, Dhruv. So itna kar lo, है ना? And try practicing the model on, try practicing on this TripAdvisor food review. That is for your self-learning, self-practice. My job for LSTM is done. ठीक है? And so jab next class mein, so I'm ending the class now over here. There's no point taking any new topic. Invest your, see guys, I am ending the class, but I am hoping तुम लोग अपनी practice चालू रखोगे, ठीक है? TripAdvisor है, food review, ठीक है? जब तक कर नहीं लेना तब तक समझ लेना कि मैं यहीं बैठा हूँ, ठीक है? करते रहना please, ठीक है? So the model would be built exactly same way. Only thing is the data is little big, so you may have a little different type of challenge, ठीक है? Try overcoming that challenge. So how to reduce the data, ठीक है? Reduce the train data or reduce the embedding size or whatever. देखो क्या होता है, ठीक है ना? First go with your TripAdvisor. I think it has some 70,000-75,000 records. Go with your Amazon food, which has some several lakh records, ठीक है? And next class में अगर सब लोग ने यहाँ पे थोड़ा सा अच्छा प्रैक्टिस किया ना, तो मैं तुम लोग को एक छोटा सा आउट ऑफ द बॉक्स जाके बाय डायरेक्शनल LSTMs बता दूंगा. Bidirectional LSTMs की कोडिंग, how to do it and what is bidirectional LSTMs, ठीक है? So bidirectional LSTMs are top of LSTMs. They perform little better than LSTMs. But as of now, please practice on this. Practice karo, take your break and keep your practicing. I'll end the session from my side. Okay. Okay, guys. So with this, I'll end the session.
Guys, please end the meeting.